At 02:34 a.m. on October 2, 2025, the USS Virginia, SSN 774, was stalking a Russian Oscar II class cruise missile submarine in the Barents Sea, 240 nautical miles north of Murmansk. The American submarine had been tracking the Russian boat for 14 hours, maintaining a position 2,000 yards directly astern, using passive sonar to monitor every sound the target made. The mission was routine: shadow the Russian submarine, gather intelligence on its acoustic signature, track its patrol pattern, and remain undetected. The Virginia's commanding officer, Commander Sarah Mitchell, 41, had conducted these operations dozens of times, but she'd never experienced what was about to happen. At 02:51, the Russian submarine made an emergency maneuver. Analysis later suggested an iceberg drifting south from the polar cap, appeared directly in the Oscar II's path on its forward-looking sonar. The Russian captain ordered emergency right rudder and emergency ahead flank. The massive submarine, 508 feet long and displacing 9,400 tons submerged, turned hard right at maximum speed. The USS Virginia, following 2,000 yards behind at a depth of 400 meters, detected the sudden course change but had less than 30 seconds to react. Commander Mitchell ordered emergency left rudder to avoid the turning Russian submarine. But at 400 meters depth, traveling at 15 knots, underwater physics work against you. Submarines don't turn instantly. They respond slowly, ponderously, like aircraft carriers underwater. At 02:51:47, the bow of the USS Virginia struck the stern of the Russian Oscar II submarine at a combined closing speed of 20 knots. The impact was catastrophic for both vessels. This is the story of the most dangerous submarine collision since the Cold War. Two nuclear-powered submarines, one American and one Russian, damaged and sinking at 400 meters depth. 73 sailors on the Virginia, 107 on the Oscar II, all facing the same nightmare: surface and risk an international incident. Or try to repair the damage at a depth where water pressure could crush both hulls like tin cans. If you're here for submarine warfare and the reality of undersea crises that most people never hear about, hit subscribe on Navy Warfare right now. And comment below: if you were the captain, would you surface immediately or try to fix the damage underwater? The USS Virginia is a Virginia-class fast attack submarine, the most advanced attack submarine in the U.S. Navy. At 377 feet long and displacing 7,800 tons submerged, it's smaller than the Russian Oscar II, but significantly quieter and more maneuverable. The submarine is powered by an S-9G nuclear reactor, providing virtually unlimited range. It carries 12 vertical launch system tubes for Tomahawk cruise missiles and 4 21-inch torpedo tubes capable of firing Mk-48 AD-cap torpedoes. The submarine's AN/BQQ-10 sonar suite is among the most sophisticated in the world, capable of detecting targets at ranges exceeding 50 miles in ideal conditions. Maximum operating depth, classified but estimated at 800 feet with a crush depth beyond 1,600 feet. The Russian Oscar II-class submarine is a monster by comparison. At 508 feet long and displacing 19,400 tons submerged, it's more than twice the size of the Virginia. It was designed for one primary mission: killing American aircraft carriers. The submarine carries 24 P-700 Granite anti-ship cruise missiles in vertical launch tubes mounted along the sides of the hull. Each missile has a 1,650-pound warhead and a range of 380 miles. The submarine also carries torpedoes and can dive to depths of 1,740 feet. It's powered by 2 OK-650 nuclear reactors and crewed by 107 officers and enlisted sailors. The collision occurred at 02:51:47 at a depth of 400 meters, 1,112 feet. The Virginia's reinforced bow, designed to punch through ice during Arctic operations, struck the Oscar II's stern section near the propeller. The impact crushed the Virginia's bow sonar dome, sheared off several sections of anechoic coating, designed to reduce the submarine's acoustic signature, and ruptured a ballast tank. Inside the submarine, the collision threw crew members against bulkheads. Equipment tore loose from mountings, and critical systems began failing. Commander Mitchell was standing in the control room when the impact hit. the force threw her into the navigation console. Alarms erupted throughout the submarine. Collision alarm, flooding alarm, reactor scram alarm, hydraulic failure warnings. Damage report. All compartments report status. The reports came in over the next 90 seconds, and each one was worse than the last. The bow sonar dome was destroyed, no forward-looking sonar. Ballast tank number 1 was ruptured, taking on water. The forward escape trunk was damaged. One less way to evacuate if necessary. And most critically, hydraulic lines to the bow planes were severed. The submarine had reduced ability to control depth. But the Virginia was still intact. The pressure hull hadn't been breached. The reactor had automatically scrammed, shut down, as a safety precaution, but it could be restarted. The submarine was damaged but survivable. The Russian Oscar II wasn't as fortunate. The collision had struck its propeller shaft and stern planes, the control surfaces that steer the submarine underwater. The massive propeller, weighing several tons and spinning at high RPM, had been knocked out of alignment by the impact. It was still turning but vibrating violently, creating noise that would make the submarine detectable for hundreds of miles. And worse, the stern planes were jammed, stuck in a down angle, which meant the submarine was being forced into a dive it couldn't control. Subscribe to Navy Warfare for submarine tactics and the reality of undersea operations, where the margin between survival and catastrophe is measured in seconds. And tell us, what's more dangerous, surface ship combat or submarine operations? Aboard the Oscar II, Captain First Rank Viktor Petrov watched his depth gauge with growing horror. The submarine was descending, 420 meters, 430 meters, 440 meters, and the stern planes weren't responding to helm commands. The crew was trying to compensate by flooding forward ballast tanks to level the boat, but it wasn't enough. They were sinking toward crush depth. Engineering, how long to repair the stern planes? Captain, we'd need to surface to access the external control linkages. We can't repair them at depth. Petrov looked at his executive officer. They both understood what that meant. If they surfaced, they'd be admitting to the Americans and the world that a Russian submarine had collided with something and was damaged. It would be a propaganda disaster. But if they didn't surface, the submarine would continue sinking until the pressure hull failed and everyone died. At 460 meters depth, Petrov made his decision. Emergency blow all ballast tanks, surface the boat, and transmit emergency signal to Northern Fleet Command. The Oscar II's ballast tanks expelled their water using high-pressure air, creating massive bubbles that rose toward the surface. The submarine, suddenly buoyant, began rising, slowly at first, then faster as more air displaced more water. Aboard the USS Virginia, Commander Mitchell heard the Russian submarine blow tanks. Her sonar operator reported, "Con, sonar. Contact Sierra 1 is emergency blowing. Estimate he's ascending rapidly." Mitchell faced the same decision Petrov had made moments earlier. Her submarine was damaged but still capable of diving and maneuvering. She could attempt to repair the hydraulic system underwater, restart the reactor, and continue the mission. Or she could surface, acknowledge the collision, and deal with the political consequences. But there was a factor Petrov didn't have to consider. The Virginia's hull was smaller and lighter. At 400 meters depth, even minor flooding could quickly become catastrophic. The ruptured ballast tank was taking on water. If she waited too long to surface, the submarine might not be able to surface at all. Officer of the deck, emergency surface. Blow all main ballast tanks. Secure from battle stations, rig for surface. Communications. Prepare emergency transmission to Submarine Forces Atlantic. At Air 256, 5 minutes after the collision, both submarines began their emergency ascents from 400 meters depth. The ascent rate was carefully controlled, too fast, and the sudden pressure change could cause injuries or equipment damage. Too slow, and the damaged submarines might not make it. At 0309, 13 minutes after the collision, the Russian Oscar II broke the surface 2 miles from where the collision occurred. The submarine's stern was visibly damaged, the propeller bent, the stern planes jammed at an angle. Water streamed from damaged hull sections. At 0311, The USS Virginia surfaced 1.5 miles away. The bow was crumpled, the sonar dome completely destroyed, and a section of the hull's anechoic coating was peeling away. Both submarines sat on the surface in the Arctic darkness, running lights on, in international waters of the Barents Sea. And both crews faced a surreal situation. They could see each other. In submarine warfare, the goal is always to remain hidden. But now, two submarines that had been playing cat and mouse underwater were sitting on the surface, visible to each other and to any satellite or patrol aircraft overhead. Within minutes, both submarines were transmitting emergency signals. The Oscar II reported to Russian Northern Fleet headquarters that it had collided with an underwater object and sustained damage requiring immediate assistance. The Virginia reported to U.S. Submarine Forces Atlantic that it had been involved in a collision with a Russian submarine and required surface assistance. At 0334, a Russian Il-38 maritime patrol aircraft arrived overhead and began circling both submarines. At 0351, a US P-8 Poseidon arrived and established a patrol pattern. Neither aircraft took any hostile action. This was a rescue situation, not a combat situation. But both were documenting everything for their respective governments. At 0447, a Russian rescue tug departed Murmansk harbor, steaming toward the collision site at maximum speed. At 0512, the USS Michael Mansour, an Arleigh Burke-class destroyer operating 80 miles to the west, received orders to proceed to the Virginia's location and provide assistance. For the next 6 hours, both submarines sat on the surface, conducting damage assessments and waiting for help. The crews, exhausted and shaken, worked to stabilize their boats. Engineers pumped water from flooded compartments. Damage control teams patched hull breaches. And both captains filed detailed reports with their respective chain of commands. At 11:23, the Russian rescue tug reached the Oscar II and began towing operations. The damaged submarine, unable to dive safely, would be towed 240 miles back to Murmansk for repairs that would take months. At 12:15, the USS Michael Mansour arrived alongside the Virginia. The destroyer's crew rigged emergency pumps and provided damage control supplies. A team of submarine maintenance specialists transferred from the destroyer to the Virginia to assess whether the submarine could make the transit back to port under its own power, or would need to be towed. By 1430, engineers determined that the Virginia could restart its reactor and operate at reduced speed. The submarine would transit on the surface back to Naval Submarine Base New London in Connecticut, escorted by the Michael Mansour, a journey that would take 12 days due to the damaged bow and reduced speed limitations. The diplomatic fallout was immediate and complex. The United States accused Russia of conducting unsafe submarine operations that led to the collision. Russia accused the United States of conducting espionage operations in waters near Russian territory. Both sides demanded compensation for damages. The truth, revealed through acoustic analysis and subsequent investigations by both navies, was that neither captain was at fault. The Oscar II had made an emergency maneuver to avoid an iceberg. The Virginia had attempted to avoid the suddenly turning Russian submarine, but couldn't react fast enough. It was an accident, a collision between two submarines operating in close proximity in an unforgiving environment. But the incident exposed the dangers of submarine operations in contested waters. Both submarines had been operating at the edge of their capabilities, the Virginia tracking at close range, the Oscar II conducting patrols in waters where American submarines frequently operated. The collision demonstrated that even with the most advanced technology and highly trained crews, submarines are vulnerable to accidents that can happen in seconds. Final damage assessments revealed the extent of the collision's impact. The USS Virginia required $47 million in repairs and was in dry dock for 7 months. The bow sonar dome was completely replaced. Hull sections were cut out and replaced, and the submarine's acoustic signature was restored through new anechoic coating. The Oscar II required $89 million in repairs, far more expensive due to the damage to the propulsion system and stern planes. The submarine was out of service for 14 months. Miraculously, casualties on both submarines were minimal. On the Virginia, 12 crew members sustained injuries, mostly fractures and contusions from being thrown against equipment during the collision. all recovered fully. On the Oscar II, 23 crew members were injured, with 3 requiring medical evacuation by helicopter once the submarine surfaced. All survived. But the incident left psychological scars. Every submariner understands that their vessel operates in an environment where mistakes or accidents can be instantly fatal. The collision reinforced that reality. For the 73 sailors on the Virginia and the 107 on the Oscar II, the knowledge that they'd been seconds away from hull breach and catastrophic flooding at 400 meters depth would stay with them forever. Commander Mitchell continued in submarine command for 3 more years before retiring. In interviews, she stated that the collision was the most terrifying experience of her career, not because of the impact itself, but because of the minutes afterward when she didn't know if her submarine would hold together long enough to reach the surface. Captain Petrov was removed from command following the incident, a routine procedure in the Russian Navy after major accidents. He was reassigned to a staff position and later retired. Russian state media never mentioned his name in connection with the collision. The collision also led to changes in submarine operating procedures for both navies. The U.S. Navy implemented new rules regarding minimum separation distances when shadowing foreign submarines. The Russian Navy improved its forward-looking sonar systems to provide earlier warning of obstacles like icebergs, and both nations agreed to improved communication protocols for handling submarine emergencies in international waters. Now I want 3 perspectives from you. First, when conducting submarine surveillance operations, what's more important, gathering intelligence by getting close or maintaining safe separation distances? Second, if you were a submarine captain in this situation, would you have surfaced immediately after the collision, or would you have attempted repairs underwater to avoid the political embarrassment? Third, should international laws establish mandatory separation distances for submarines operating near each other, or would that compromise national security operations? Comment your detailed tactical and policy analysis below. Your insights drive the conversations we have on Navy warfare. And if this breakdown of the most dangerous submarine collision in modern history gave you new understanding of the risks submariners face every day, prove it by hitting that like button, subscribing to Navy Warfare, and turning on notifications. Because when 2 submarines meet at 400 meters depth, survival depends on seconds of reaction time and the strength of a pressure hull. Until next time, stay informed, stay tactical, and remember, under the ocean, there's no room for error.